Hello, everyone. Thank you for joining us for the next episode of our Startup Spotlight series. My name is Anna. I'll be your producer for this session. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenter to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speaker for today. Thank you so much for joining.
Yeah, so I guess we are live. So hello everyone. Uh, my name is Naman Vyas, and I am a software engineer at Middleware. We are an observability shop, so we will be talking about monitoring only, and more on the side of alerting. So the title is precision, as you can read, precision monitoring, leveraging data correlation for effective alerting. So for start of this session, we'll imagine a bad day on an for a SRE on-call engineer. So on a bad day, he sees notifications like this popping up. On some service, like a payment service, his CPU utilization is high. Then another alert, error rate exceeded some threshold in the checkout API. Some pods are getting restarted, so that's being detected in the user profile worker. This can be anything, right? These are just examples. There has been a latency breach of threshold. So in the order service, the latency is pretty high, and the connection pool has exhausted. So for the Postgres, the connection pool is being exhausted, so no new connections are being made. And the health check API is finally failing. So in the East Gateway East instance, your health check is failing. And then in the recommendation engine, there is memory pressure. So it's I would say it's really easy to get overwhelmed when you see so many alerts firing at the same time. So with so many directions, so many pointers, what do you solve first? And remember, right, like going in all the directions, throwing stuff at wall and seeing what sticks is just like going nowhere. So which do you solve first? And we will be trying to, in this talk, we will be trying to create like a mental model uh, on creating first of all what to monitor, and then on what to alert. So just like from a survey, like the state of digital operations done by PagerDuty, it said that like an average SRE or on-call engineer receives 50 alerts per week, and only 2 to 5% of them require human intervention. So uh, it's like 95 to 98% of those alerts or those pages you see is just noise. So the problem is we didn't actually build bad alerting, we just build too much of it. So what I want to talk today is not how to add metrics or alerts, but like how to build smarter ones, like the alerts which are grounded in correlated signals across all the three observability pillars: metrics, logs, and traces. And so when you have your phone being paged at in the middle of the night, you actually wake up for something that's worth waking up for. So before correlation, first we will have to fix something that's wrong. Actually, I've seen people alerting on the wrong metrics, not misconfigured, not like improperly, poorly tuned, but wrong. And they are chosen because they are easy to collect, not because they describe how system is actually failing. So there are two frameworks we will be discussing here. They are pretty famous ones. It is called the use framework and the red framework. Use framework is uh, presented by first coined by a chap called Brendan Gregg, and he's kind of the goat in system performance monitoring field. He has pretty great blogs and even greater talks and a nice little book. So like shout out to this guy if you want to read this blog. It's gold, and I would recommend you to read this. He talks about system monitoring for the applications, uh, for the applications, for the resources, for the networks. It goes from CPU to the users. So, great guy. So, how do you pick the right metrics? That's the question, right? So, how people generally pick metrics, as we said, like they use the tools method. So what they do is like go y- is they select like what performance tools are available. Let's say Prometheus or open or you're doing with hotels open telemetry, and for that particular tool for that particular integration, check what metrics are exposed, and then for that particular metrics for that unit, they just ask like what would be a good threshold and have an alert on it. So Greg points out the problem pretty well. Like it relies exclusively on availability of available or known tools, so which can provide the incomplete view of system. So user is actually unaware of what he's unaware, like he has this incomplete view. There are unknown unknowns. So you are more the things that the things that bring down your system are technically not visible to you. So that's the problem. So we'll straight away jump to the framework that Greg likes coined. It is the use method. To sum up the entire framework in a single line, it's like for every resource, check utilization, saturation, and errors. So that's it. You can like log off right now and think about it, and the talk will be over. Just kidding. So what is actually utilization? It's just the percentage of the measure of how busy is this resource over a certain time interval. So let's say if the resource is your CPU, then it's just a percentage of how busy your CPU is for that particular interval. So saying like a user yeah, the resource is busy like 90% of the time, so it is like for 90% of that selected interval it is busy uh, processing. Same way for disks. Or even if you say same way for your network interfaces. Then is saturation. This is kind of my favorite. So saturation is the like measure of how much work is queued for that particular resource, which that resource is not being servicing. So it's like the backlog of tasks for a particular resource. So let's say if a CPU has a run queue of length 4, that means there are 4 processes waiting to get turned on a CPU. So that's saturation. And errors, like it is simple like scalar counts how many failure events. So for a network interface, like that would be that there are 50 late collisions on a NIC card. So you just keep it as a scalar and just see the rates or the graph of it. So for every system resource, if you plot with these three, like usage, utilization, saturation, error, have a matrix of it and convert it into a dashboard, that is usually pretty much uh, enough for what's choking your resources. And that's the thing we recommend at Middleware if someone comes with their infra to monitor. So you can see in the examples that I've shared, you can see that I have specifically talked about hardware resources, right? CPU, disk, etc. But what about software resources? So use can be also applied to software resources as well. But before that, there's this thing I need to talk about, that is the saturation trap. So imagine an example like where let's see this example that Brendan Gregg said. So there was this customer who had CPU problems with CPU saturation. So there was latency, but their monitoring tool showed that CPU utilization never went higher than 80%. So what could be the problem? Like, does low utilization means no saturation? What's the problem? But the problem is the monitoring tool was reporting on 5-minute averages. So which means that during the 80% is the average, but during a 5-minute interval the CPU was shooting was spiking till 100%, and for that brief moment the user was suffering with latency. So averages tend to lie a lot when we are talking about uh, hardware resources. So we need to keep this in mind. The So with this, like, if there is saturation, any degree of saturation is needed to be reported, like not a trend or not a threshold, but if it is non-zero for certain amount of time, you report it. So as I said earlier, I was jumping ahead, but as I said earlier, there is this uh, difference between utilization and saturation. So utilization means like it's the lagging indicator, but what is the leading indicator is the saturation, because saturation, after saturation comes the utilization, and people generally tend to alert on utilization only. So if you are doing alerts on saturation, you will be maybe able to uh, catch problems and solve problems before they become a problem, before your CPU chokes. So just a mental model here, like if it is utilization is how busy is my resource, so and saturation is any work queuing, so how busy will be my resource. So that's that. And as I said earlier, you use use framework apply to software too. So for example, let's consider our mutex lock a resource. So utilization for a mutex lock is the time that the lock was held, and saturation would be the threads that are waiting to acquire the lock. You see, there is a trend here. If you are thinking about a thread pool, like a number of threads, so the number of threads that are busy processing is the utilization, but the requests that are waiting to be picked up by these threads is the saturation. You can draw the same for like connection pool or some consumer of your like queues, like Kafka or Red Panda. So people generally see use or follow this use framework, but they seldom set alerts on software resources as well. So there's this great example that I wanted to share with you. It was like a great day for mankind, like a huge leap for mankind, as the president said. So on July 20th, 1969, T minus 6 minutes to the lunar landing, uh, the alarm started to fire, like the alerts were starting to fire. So these alarm 1202 and 1201 were the alarms for, like, there are some jobs in the CPU that are being like left, that are being ignored. So what actually happened? Like there was this radar called uh, there was this computer called the Apollo guidance computer, and it was kind of concurrent. So it had this job scheduler, but every job that used to come to this scheduler came with priority levels. So if they had 7 cores, there were registers for storing program sets for each and every job. So this is kind of like our thread pool, right? So the problem was there was this one job called the rendezvous radar that was not needed for landing, but it was interrupting AGC continuously. So there were things that had more priority than the rendezvous radar, and they were being evicted. So what the AGC did at that time in 1969 was gave no priority to the rendezvous radar and evicted it. So that like 1202 literally means like executive overflow. We don't have any sets, and then 1201 means we are evicting some uh, low priority jobs. So, like, do we think, for example, in our case, if there is a connection pool, ha- we don't even evict, like, we don't even have monitoring on what things are evicting as of now, even. But like in 1969, with 4 KB of RAM, they had this intelligent eviction. So, like, that blew my mind. So, as you can see, the saturation principle was on work here. As it was being saturated, the things that were the jobs that were not of use uh, were sent, were evicted. So the use framework generally answers this question: is my infrastructure healthy? Are my resources healthy? But while we are monitoring, we are thinking about two workloads, not just the infrastructure, but applications as well. So what about applications? Well, that's the next framework. That is the red framework. But before that, I just like want to quickly show you how easy it is to alert on a infrastructure metric using middleware. So let's say that you are on the home page of middleware. Let's go to a new tab, and let's head the home page of middleware, because I want to show something from here afterwards. So we go on, like, my this current monitor laptop, the Latitude laptop is being monitored with the middleware agent. So if we want to set alerts on any of these resources, we can do it just like very easily. So we go to add new rule, and we can set like monitors on anything, like any metric for any integration, just the metrics of the host. So like how the host is performing, like system level metrics, monitor on any logs, any traces, real user monitoring. We can set alerts on any of this, but for like the sake of this talk, we will create a alert on a host metric. So let me scroll down, and I want to, this is comfortable, cozy, right? So I want to set a metric on system CPU utilization. So this is the system CPU utilization of my current laptop since past hour. And if I, let's say, do I want to average by? Because again, we learned that averaging on system CPU on CPU is not the correct way. It hides the burst. So we will select max by, and then we will set alert condition. So for this metric, what we want to set the threshold. So let's say like I want to have a warning threshold of, let's say, 90%, and the critical threshold to be 95%. All right. And again, as I said, this is the evaluation window. So what evaluation window is, like, for the span of 5 minutes, if the average, let's if we select the average for the span of 5 minutes, for this metric, for a window of 5 minutes, is my average above the threshold? If it is above the threshold for this time, this like period of time, only then we want to shoot the alert. But again, as I said, let's not do that for, like, because it would not be suitable for our current metric CPU utilization. So we will set the max, and let's say monitor name is my bad, CPU utilization and spikes. We can also like have tags, so we can group our alerts together based on tags, kind of like a namespace. And that would be it. Oh, sorry, my and on which channel do we want to be informed. So I want to be informed on my email. Do you want to set custom alert message? This will come in the alert. So it's pretty much basic stuff. And with this, we are good to go. We can create an alert. Okay, get notification when the error resolved, and notification also when there is no monitoring. So that's important for your infra. So that's that's it. But what I also want to share is, like, we are in the uh, AI age, right? So there are the new users. They also like not to perform these things. So we can, like, also do we can also use our ops AI. So just saying that create an alert on CPU utilization on current hosts, and it will make the whole alert rule for you. And if we apply config, a new alert will be generated. So that's that. It's that easy. So you don't even need to manually check for it. An interesting thing, these thresholds will be selected by the AI only. So the the warning threshold was selected like 0.9%. So it's, and this was 0.95%. So okay, we need to specify 70%, not like 0.75%. But that's AI, right, for you. All right. So let's get ahead and go to the application land from the resources land. So for application, for microservices, it's the red method. It is like coined by Tom Wilkie. He started working with ViewWorks. He was previously working with Google as an SRE. He was like the on-call engineer for Google Analytics, and he is currently working at Grafana Labs. So first, why use is not enough uh, for the services? So, like, memory utilization is tricky. He says that memory utilization is tricky. What is it? What do you actually count? Like, the cache of memory is also kind of weird one. So what is a saturation? Like, is it the page faults, or how many times like paging is occurring? So uh, use has its problems when we come to the microservices land. And so how what is red actually? So red is, again, just the three metrics: rate, errors, and duration. So for a microservice, what you want to do is want to read requests per second. How much load is this service handling right now? Then you want to also see errors. Errors will be present in both of them. So like failed requests per second. If we are talking about requests, then failed requests per second, like how many requests are going wrong. And thirdly, it's duration. So what is the distribution of response time? Like, not average, the distribution, like the P50, P90, P90, P99 at the minimum. So, and we'll again come back to why not average, and this should be consistently applied to every service in your architecture. So why this helps actually? Because if every service in your architecture is speaking this language, it is fairly easy for the guy who is on call, who has not written those services, because every service is uh, speaking the same language. So uh, and we have a uniformity, a shared language across every service. So why these three? So, like, everyone should understand the error rate, the request rate, and some distribution of the latency of those requests. I said this earlier. So we need a consistent view of how your architecture is behaving. Now let's go to certain shapes, like and create a mental model around the shapes of the red metrics. So, like, if your rate is going up and your errors and durations are stable, this means uh, money in the bank, healthy growth, and you probably need to capacity plan. like for more resources, system resources, but that's further down. If the errors are spiking but rate and duration are still stable, then there has been a bug or some dependency failure. If the duration is going up and the errors and rate is similar, then there is probably a performance regression. And if rate is suddenly decreasing, then there has been an upstream failure, and you will be not be seeing like duration and errors because the requests are not coming only. So if you alert on like rate above a threshold, if you just alert on a rate above threshold, you will be blind to these other three. So why distribution like P99, as I said earlier, will beat average? Because imagine your payment service, right? And it is handling, let's say, 1,000 requests per second, and 970 of them are being completed in like 80 milliseconds, but 30 of them are hitting some slow code path, like it is set taking 4 seconds. So your average latency is about 196 millisecond. It looks slightly elevated, but it's not alarming. You have not sent alerts on, no alerts will be firing. But if you see your P99 latency, it is 4 seconds. So one in every 100 requests is unacceptably slow. So an alert on this and an alert on this P99 will give to you your most miserable user, like who is suffering a lot. So we need like P99, not just the average. So how do you make alerts on like rates and all? So let me show you our platform again. So let's say your services look like this. Okay, this is my like demo service. So there is a catalog service, load generator service, API gateway, order service, and two of them are using database, and three are like the regular post services, like web services. So if I want to set like an error on the request, here are the total, like the total counter of request, but the rate of request, like the request rate or the error rate, how will we go about doing that? So let's head straight back to alerts again. And it is as easy as selecting APM. And now you can see you can set alerts on almost everything. So your P99 rates, your P95 rates, your P50 rates, your app-dex scores, your error rate, your total error count, and the process is same as we did on the metrics. So let's quickly do an error rate. Okay, now again it is my demo service, so I'm like uh, uh, I'm purposefully creating more errors here, but we can set threshold. So first of all, okay, average by error rate on average by looks perfect. It's no problem. We can use average there. And let's say that if error is greater than 5%, give me a warning. And if it is greater than, again, this actually is unacceptable. People usually do 1 or 2.5. And if it is like hitting 5%, sorry, if it is hitting 5%, set the we set the critical threshold. Again, select the email ID here, and we also need to get notified, and yeah, we also need the graph. So that's it. We need to still have a name for it, error rate, and 5-minute window per 5 minutes, and let's say average error rate. Okay, so with this we can create now. Okay, rule name is required. I just gave a rule name, right? Just a moment. Okay, now it's all right. Average error rate, and we have a rule here as well. So maybe we'll keep this running, and maybe at the end of the session we will see if we have received some notifications. So as we discussed previously, uh, use says, are my resources happy, are my computers happy, like, is my infrastructure happy? And the red answers, are my users happy? So that's the difference. But honestly, we will use both of them together. It's like red method. As I said, red is about caring about about your users, how happy they are, and use is about caring about your machines, how happy they are. They are just two different views on the same system, and they are complementary. So we'll view the combined picture. Let's say, take an example. If the user is saying connection pool saturation is 47 and it's growing, red will say, yeah, probably my P99 is now hitting from 90 to 4 seconds. Together, it will tell you that payment service is slow because connection pool it is dependent on the payment services depend on the connection pool, and the connection pool is saturated. So again, if you run a practical uh, comparison, so the saturation, like in infrastructure during use method, if there is saturation, we fire immediately. If utilization is crossing, we alert as a warning. And if errors, always investigate. So in red, error rate is the percentage of your total requests. Duration is the duration on percentiles and not averages. And if the rate drops, alert on these. So and that's it. So the metric, this is the metric that we are most people miss right now, is like they have saturation. People use saturation on hardware resources, but they don't use saturation on software resources. So this is the metric most people fail to use. And then we have discussed this earlier, how like use can be applied on software resources as well. So the problem is, like, this will tell you what to alert on, but neither will tell you why the alert fired. So again, with this, these are the best practices, but when the alerts are fired, you will still have to figure out, you still have to view in your logs and your traces, not just your metrics, to figure out the exact problem. So what's the bridge between logs and traces and the metrics? So when metrics fires, use and read on metrics, and we fire on the alert. But traces will tell you like which span exactly took the most time, and with that span you will be able to find the code which was taking the most time. And with log will tell you why it was happening, because if you had correct logging, it will you can correlate with that span and log that why exactly it happened. And metrics will give you the idea how bad was it, how bad was the outage or the incident. So we will see 5 failure patterns. Probably we will see uh, why like why single signal alerting breaks, and why correlation is actually needed. So we have already done this demo. So like we start with the first pattern, that, and I like to call it the cascade masquerade. So there is only one root cause, but there are many alerts. So most of the alerts are actually the symptoms, but a very few or very one of them are just the cause. So let's say there is this incident. Okay, so it's again the nightmarish scenario in the middle of night, and your payment service error like jumps from 4% to 31% under 3 minutes simultaneously. the latency has breached in your order services, your pods are restarting. The whole picture is the first one, right? The first slide. So your on-call engineer wakes up to the wall of notification. Now every threshold was genuinely crossed. The monitoring system is doing its job, but the engineer has no idea where to start. So if we see all these three pillars in isolation, metrics is telling you everything was fire, and it is pointing everywhere. The logs alone, if you see the logs alone, there are different error logs on different services, and they look like independent problems. And if you see traces alone, like per service traces, they are broken at the boundary, so you cannot see the cross service view, and none of them are telling, oh, which is broken, and we are just reacting on it. So if we want to see the correlated picture, we need to ask, like, what changed first during this pattern. If like everything seems to broken, you have to ask, like, what was the thing that blasted first. So at t0, so you will find uh, the traces, and you will find like the timestamps. And at t0, the connection pool exhausted, and you found this warning in the logs. At t0 again, the connection count, like the Postgres or your database connection count metrics, it is hitting the ceiling of the threshold. And after 90 seconds of that, you will be seeing that the service metrics are starting to fire. The service metrics being like the request rates are increasing, and the rates are also increasing, and the uh, duration is also increasing. So like these are the lagging indicator. So the database signal fired 90 seconds before any of the service alert. It fired quietly, and it was buried under noise in a pillar that nobody had an alert on, because people sometimes don't do alerts on logs as well. So if we want to see a correlated picture, how does it look like? So all these three together, we can answer like what is broken, but why it was broken, what was the upstream dependency that broke the downstream dependees. So there is this real life scenario of Discord in 2020, and Redis primary like node was dropped, like was migrated, and the node dropped offline. Like it was a known bug. So from the outside, like dozens of alerts across like completely different services, parts of the stack. From the inside, it was just one infrastructure event, like a GCP initiated migration. No application level metric would have ever caught it on its own. So it was visible in the infrastructure edit logs and distributed tracing or timings of the distributed tracing, but it was invisible in every application related level metrics. So what kind of mental model can we have on well, okay, I was seeing some chat. So what kind of mental model do we want to have? uh, the first signal, always remember, like the first signal is rarely the loudest one. So in when a cascade happens, the root cause fires quietly and early, and the noise comes later, like from everything downstream reacting to the first one. So if you're tracing by which alert, if you're tracing by which uh, alert was this happening, you have to go backwards in time and see what fired first. So the rule is, when multiple alerts fire simultaneously, stop looking at the service and start looking for the shared dependencies all those services have. So what was shared across all of them? Of course, the Postgres, of course, the database in our example. And in the in the Discord's example, it was Redis. So that's the mental model I want you guys to have from now on. And that's it. Now, the second pattern, the silent degradation one. So you know what's more terrifying like than 30 alerts? It's none. Green dashboards, complete silence. So your on-call engineer is asleep. Your SRE lead checked everything at 10 p.m. and said, "Yeah, all good," and that's it. Your CEO just tweeted about your uptime. Like we have been servicing 99.999% of time, but the infra is secretly dying. So in what are the patterns or what are the patterns in your telemetry that tells you this? So if we look at the isolated pillars, CPU threshold is set at alert threshold is set at 80%. The metric CPU is 72%. The error threshold is at 3%, 0.3, and the threshold is at 1%. The everything like even the latency is under the threshold. So same goes with the logs and the traces. But the problem is these are approaching towards the threshold. So the metrics are telling you the truth, but the threshold is lying by omission. What does this mean? So if you look at the error, if you look at the graph, you will see that memory utilization is jumping, like your resources are jumping from 61 to 74. Like there has been a consistent trend, and there are upstream trends on this. So during an upstream trend, if you have not monitored, if you have monitored on the absolute values, you will only get the value at when the trend crosses the threshold. But we want that? Effective alerting would be catching the alert, like catching the problem before your alert even fires. So like if this is your threshold, we want to monitor the slope and not the cliff. So we how do we monitor towards a slope, right? For that, we will monitor on the rates. So not the memory utilization itself, but rate at which memory utilization is growing. And if that crosses a certain threshold, your memory utilization may not have reached a threshold, but you can see there is a trend incoming, and we will be able to debug before a problem actually occurs. So in 2010, Foursquare, their MongoDB fell over when it ran out of memory. Like it had 17 hours of downtime, and this incident spanned across 2 days. So when every user check-in read the entire check-in history for that user, and records had almost no cache reuse. So memory pressure was building slowly for hours, and then again after the slope comes the cliff, and after the cliff there was downtime. So uh, whenever you try to monitor, you should also set monitoring on alerts and on the rates, and these rates will save you downtime. This will tell you something is wrong before uh, you have downtime. So again, threshold, as I said earlier, threshold protect against cliffs, but correlation protects against slope. So alert on rate of change across all these pillars, not the absolute value, will protect you against this kind of patterns. So you can build on like log volume trends, like the number of logs that are coming, like the number of error logs. You can build on that, and that's your basically your slope detector. Now the third pattern, the lying metric. Again, we touched upon this previously. The lying metric is something that is statistically accurate but operationally useless. So again, this is the same example as previous one. So CPU never went about 80%, and but users are experiencing latency spikes every few minutes. So during a 5-minute average, there are 30 seconds where there is a burst of 100% utilization. So how do you catch it using correlation? So every logs need to be time stamped per event. These logs will see the bursts, and the raw per second metric data will confirm it. So, and then you will find out the outlier trace with the P99, and find out like which trace for which user is exactly suffering with this problem. So fix is not use average but max, and max across like not a huge window, 5-minute window, but a small 1-minute window, and alert on P99, not average. So this one is also a fun one. So the upstream impersonator. So the loudest service is rarely the broken one. So in the war room, the payment service is 34% error rate, and 45% of debugging time is wasted on the wrong service. So the distributed trace says that the API gateway, the payment service, in user profile service and database service. So these are the spans across your distributed trace, and users profile service user profile span is actually having let's say 8,000 milliseconds, but in that the database query is 8,190 milliseconds. So the payment service was innocent, but there was a connection leak, and the connection kept growing and growing, and the database eventually uh, said that I don't want to accept any more connections. So your infra guy will come and just restart the database again. That's not the right way, right? So rarely like the one you could have monitored this on the database one. You could have monitored like the number of connections leaving a threshold. So instead of just looking at the traces, you have to correlate the traces and the metric also. And the latent time bomb, again, this is the uh, same kind of the same thing as the silent degradation one. So like uh, if you guys remember Google Shakespeare search, there was sonnets and poems that were discovered, and it went viral. So like millions of search keyword came, and the keyword was not in the corpus. So this started a resource leak, and this led to 66 minutes of downtime in Google. So how you could have caught it? You could have caught it using tail-based sampling. So only use the slow searches, clustering by the query type, and you can also use like log pattern detection. So if there are new types of logs that are coming, you can use something like drain or some algorithm to find out new log patterns. And of course you can use like histogram alerting. So no results query should be an outlier, like an latency outlier. So what are the 5 rules that we have learned from the Cascade masquerade? The first signal is rarely, and the main signal that has caused problems downstream, it is rarely the loudest one. During the silent degradation, thresholds protect against cliffs, and correlation protects against slopes. More like correlation and rates on that correlation protects against slope. Third one is the lying metric. So your aggregation interval is destroying the signal that would have saved you, and like the average one, right? So bursts could have saved you, but your aggregation interval is large and you are averaging it on it, so you never find out essentially the CPU utilization metric is lying to you. And in the fourth one, the alerts will tell you who is suffering, traces will tell you who is responsible, and silence is not safety. Again, we learn it in the silent degradation one as well. So like from the Monday morning, or from tomorrow, or from later on when you are on call, or doing some metrics, setting up some dashboards, what you will do is audit your metric selection. So for every resource, use the use method. So like for you will use usage saturation error for network, usage saturation and error for CPU, and create like a matrix of uh, dashboards of widgets, and red for every service. Add saturation alerts. These are the most this is the most important one. These are the lifesavers. So also saturation alerts on software resources, so on correction pools, thread pools, lags, etc., consumer lags, etc., and switch average to max on signals like the CPU utilization, and error set an alert on rates and the trends, not just the spikes, and build a log volume trend also. So if the log volume is increasing, build a alert on that trend as well. So, and make sure your traces are distributed, like they are cross service and not per service. So that was it. uh, Again, what is the mental model shift? Like, your alerts are not your monitoring, they are the surface of monitoring. But when you get an alert, they are just the starting line. When you go to the depth, you will see that correlated context across all the three pillars, metrics, logs, and traces, is what will give you the answer of why that alert was fired. So you should build your monitoring, your architecture of monitoring for that depth. And if you do this, your on-call guy will thank you for it. So that was it. If we can take any questions or see any comments. I see. So these metrics are for, like, I'm watching on my mobile. So okay, so these metrics, uh, some from the come from it may be like come from the service by default. Yeah. So what happens is, if you see, if you integrate like any integration with middleware, I've just integrated my host. So if you go to the infrastructure one and see my laptop, you will see the metrics by default. So these are your dashboards. This will come by default. Again, my CPU is going like crazy right now. So yeah. And if and for like metrics is for your integrations, we talked a lot about connection pools and Postgres and databases. So you can uh, go to installation and perform installation of some integration. Let's say Postgres, Postgres SQL. Let me zoom in, and you do the setup. This metrics will come by default. I think I have a sandbox account on which I have some dashboards, so you can see, like, I have generated some traffic here, so you will be able to see uh, some metrics for Postgres as well. So yeah, this is like my default dashboard. You can create this dashboard like you do in Grafana, albeit a more easier. And yeah, so these metrics come by default. Now we can see, how do we reduce storms. Okay, so for reducing like alert storms, Mike James has asked, how do we reduce alert storms? We reduce like the whole talk was about that. We reduce alert storms by setting up alerts using a framework which every SRE knows, and not by like creating alerts on every metric that uh, your integration or your observability provider gives you. So for like again resources, use the use method, the utilization, saturation, and the errors. And for your services, use the red one, that is like the rate of your rate of your service, like the error rates and request rates, etc., the errors and the duration. So that's that. uh, Hello from Nigeria Delta. Hey, hello from India. Uh, and the next question is, everything you covered applies. Okay, everything you covered applies to traditional microservices. Does this translate to LLM based systems? Those failure modes seem completely different to me. bro, if I like had something like a prize to give, this is a really nice question, because how many times have you guys felt when I have felt this myself, that whenever I am using Claude and a new model arrives, the previous one, let's say a 4.7 is arriving, sud- it happens many a times. I don't know if this happens to me, but the services are up, the rates of the tokens that are coming into my screen are all right, but the response have degraded. So like use, read, all of these are perfect, but the quality has degraded. So in LLM land, you will have to also have metrics and on uh, evaluations of your prompts. So how LLM providers do this is, they have uh, they have their standard LLMs, like the gold standard ones, and they are actually auditors of of the like a small distribution of the responses that your LLM is generating to users. And if the auditor LLM is raising flags that the quality of this one is bad, then they will create an error. And we on middleware, it is actually possible. We have LLM observability made just for that. So I hope that answers your questions and enjoyment. Uh, Again, slides for this is public. It is available on my GitHub. I can share it right here. I'll I'll share it in the chat. Uh, and yeah, and also I would really like if you check out Brendan Gregg. Okay, I will shill shamelessly for this guy. Uh, his talks are top notch. You can find him on YouTube as well, and he's the guy basically behind Flame Graphs. So yeah, he knows performance. So how is it different from Datadog? Like how is it how it how it- we are the things that we have talked are pretty much platform agnostic. Uh, so that's that. So like we have talked about principles, and if you want to see like how it is different from Datadog, like we'll have to extend the talk a lot more. So yeah, that's it. Uh, if there are any more questions, we still have 2 minutes. If not, then I guess we will be concluding our session here. Like we are actually quite on time. We finished earlier, but that's nice. Anything that you want me to go? It was amazing session. Hope someday we will meet in person. Yeah, sure, man. You can find me on LinkedIn or my GitHub. I have shared. We are Naman47 Vyas on GitHub. Okay, so that was it, guys. Have a I wish you sleepful nights, and if you wake up to an alert, I wish that you guys have great alerts, and it's something worth waking up for. All right, bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.